Hello everyone, welcome back to another BGCSE past paper review. Today we're reviewing a combined science paper. This is a paper 2 from the year 2019. Please remember, before you start the examination, always write your school number, your candidate number, your surname, and your initials. Again, please remember to read through the instructions carefully, and if you have any queries, clarify them with the examiner before the examination begins. Again, for this combined science examination, they generally provide you with a periodic table, which is a very cool thing. And again, you can use the periodic table to answer any of your questions. All right, so let's go into the first question. The first question reads that this question is based on atomic structure and the periodic table. You may use the periodic table to help you. So the first question for the first part of the question for question number 1, which is part A1, is a state the atomic number for this atom. All right, so what you need to know about this or to determine atomic number are very few things. So let's quickly run through them. For this atom, the first shell has 2 electrons there. The second shell has 1, 2, 3, 4, 5, 6, 7 electrons in total. But I want you to know that the second shell can hold up to 8. Matter of fact, the third shell can go up to 8 as well, and the fourth shell can also go up to 8. But the first shell is always 2. All right, so what you need to know as well to answer this question, or I need to remember, is that the number of electrons, so let's say number of electrons, so the number of electrons equal to the number of protons, all right, and also equal to the atomic number, okay? So all three are actually equal. So the number of electrons, number of protons equal to the atomic number. So here we have a total of 9 electrons. So there are 9 electrons here. Let me quickly put that on. So right here we have a total of 9 electrons. All right, so 9 electrons in total. 2 on the first shell, 7 on the second shell. So what we know based on this, that the atomic number has to be 9. Okay, the atomic number has to be 9. Now for part 2, it's a state the total number of particles found in the nucleus of this atom. All right, so what's going to be the total number of particles in the nucleus? The nucleus contains the nucleus contains 2 particles, which is the neutron and the proton. So the protons and neutrons, they are found within the nucleus of the atom. All right, so what you need to know now, how to find the number of neutrons, because we have the atomic number and we have the number, we have a proton here. And so what you can do is to go into your periodic table and look for this element, and you'll notice that it is fluorine, and fluorine has a mass number of 19. So the mass number, let me just quickly show you that. The mass number is equal to the proton plus the neutron, okay? The proton plus neutron is the mass number. And in the nucleus of the atom, you have proton and the neutron. All right, so to determine number of neutrons, all you need to do is to minus the proton from the mass. Okay, that's a way to go about it. But once you look in the periodic table, you see the mass, that's the total number of particles there, and it will be the mass number of 19. Okay, so look in the periodic table for fluorine, you see the mass number of 19. All right, and so 19 is the proton plus the neutron, and those two are found within the nucleus. All right, so pretty much part 2 is asking you for the mass of the atom itself, all right, which is 19, the total particles within the nucleus. And for part 3 is to determine the number of neutron in this atom. And again, to find the number of neutron is the mass minus the proton. And so the 19 is the mass, the proton is 9, which is the atomic number, same thing as the atomic number, so this is going to be 10. All right, so that's going to be 10. And again, you can always look at the periodic table to assist you. The number of neutron is not shown in the periodic table, however, but you know that the mass number is there and the atomic number is there. As a matter of fact, let me just quickly show you something. Because some periodic table may be a little bit different. But this is a standard periodic table that they will provide you with in the examination. And so you should always look at 2 numbers. You have a small number and a larger number. The smaller number is the atomic number. For example, fluorine is 9. And the bigger number is the mass number. And in this case, for fluorine, it is 19. Okay? All right, so just wanted to know that as well. All right, so easy way to look at the periodic table, determining your atomic number and your mass number minus the atomic number from the mass number, get your number of neutron. All right, for part B is to identify the name of the group and the period to which this atom belongs. All right, so I want to know the group and period. Now, group is based up on the valence electrons, which means the electrons on the very last shell. So we go back to this atom again, and the last shell, we have 7 electrons. That means it is in group 7. All right, also you look at the periodic table as well. Look for fluorine because we know this is fluorine based on the atomic number. And it said the period number, the period is based on the number of shells. And so in this atom, we have 2 shells, the first shell and the second shell. So this is in period 2, okay? All right, so this is really talking about atoms and their properties and their structures. All right, so for part C, it said the atomic structure of magnesium atom. So draw the atomic structure of magnesium. Now, what you can look at the periodic table for magnesium, you'll realize that it has an atomic number of 12, which means there are 12 electrons, right? So I'm going to show you something real quick. So there are 12 electrons. I'm just put E minus there, mean electrons. They have 12 electrons. So the electron configuration going to be 2 on the first shell, then 8 on the second shell, and then 2 on the last shell. That's a total of 12 electrons, right? That's how you distribute the electrons. The first shell is always 2, 8 on the second shell, and then the remaining will go on the third shell. Again, so just remember that the first shell is always 2, second shell 8, third shell 8 maximum, and the fourth shell is also 8 maximum. So in terms of drawing this now, what you're going to do is to draw the nucleus, and you can represent the nucleus by putting P and N in the nucleus, but also you can just put the symbol of the element as well. So this case is magnesium. We're going to put Mg in the middle, representing the nucleus of magnesium. Then we're going to draw our first shell. So that's our first shell. All right, so we're going to have 3 shells, first, second, and third. And so the first shell, we have 2 electrons. I'm going to put the 2 electrons on. I'm going to use X's for my electrons. So that's 2 electrons on my first shell. I'm going to draw the second shell. And the second shell has a maximum of 8. We're going to put the electrons in pair on the second shell. So put them in pairs. So 2 right there. All right, so 2 on this side right here as well. 2 right here, 2 on the bottom, and 2 on the next side. So here, all right, I think I'm drawing that one a little bit too big, but now no problem. We'll fit the other 2 in. All right, so we're going to draw the last shell now because remember, so this is 3 shells. And so our last shell going to be this. I'm going to put 2 electrons on the last shell. You can separate these as far as possible from each other because electrons do repel each other. All right. All right. So the structure of magnesium will look something like that. Well, not something like that. It will look like that. Of course, you're going to draw it neater. Part D now is to state the charge on each of the particles found in the nucleus of the atom. And so, as I mentioned earlier, there are 2 particles found in the nucleus of the atom. One is a proton. So we have proton here. And we have also neutron. So they are the 2 particles found within the nucleus. Now, the proton is positively charged. So the charge is going to be a positive charge. All right, so going to be positive. I'm going to put the positive sign in bracket. And the neutron, they have no charge. All right, so it's a 0 charge. So 0 charge or no charge. So whatever you want to write, that's fine. All right, so 0 or no charge, and you can put the 0 in bracket. All right. All right, so those are the particles that are found in the nucleus. And so the overall charge of the nucleus is positive, right? So explain how atoms have no overall charge. All right, so why the atom has no overall charge? And remember now, it has electrons which are negative, all right, and protons which are positive. But I want to go back to show you a statement which we made earlier. And this is a statement that electrons equal to number of what? Protons. And that will help us answer our question. Electrons are negative, protons are positive. So if you have equal number of positive and negative, then the overall charge is going to be 0. All right, so let's quickly mention that. All right, so we're going to say atoms have equal number of protons and electrons, okay? So, and since you have total number of protons, electrons, so we're going to say hence equal number of positive particles, equal number of positive particles, number of positive and say negative and negative particles. All right, so equal number of positive and negative particles. All right, resulting in a zero charge. All right, so there's no charge there because you have equal number of positive to equal number of negative. So overall, if you had same number of positive and same number of negative, then the overall charge is going to be zero. All right, it's just like you have 10 things and hold 10 things. Technically, you have nothing, right? So the same thing with the negative and the positive situation. Now, for question number 2, this diagram shows the internal structure of a leaf. So this is a leaf structure question. And so they point out 2 structures on this leaf, P and Q. And actually, we can quickly label P and Q. And P is the waxy cuticle, that's the uppermost part of the plant, the outer covering of the plant. So the waxy cuticle. All right. And then Q now, it is the palisade mesophyll cell. So it's a palisade mesophyll cell. All right, the palisade mesophyll cell. All right, so that's what it is. All right, so let's go into the question now. This is exactly what the question is asking us. And it said, name the structure that allows gas to enter and exit the leaf. So the structure that allows gas to go in and out of the leaf, this is actually called a stomata. All right, and so the stomata is located here. I could just make a little marking right here. So this is a stomata, just to show you. That's a stomata there. That where gases enter in and out. Right? That look like a point in the guard, so let me just erase that. It's just a space. I think I go a little bit too high. Yeah, so that's the space I'm talking about here. All right, yeah, that's a little better now. So yeah, that space is the stomata that going in and out of the leaf, right? Gas go in and gas comes out. All right, so it's a give the name of one gas needed by the leaf and state its use within the leaf. All right, so one gas is needed by the leaf is carbon dioxide. Matter of fact, there are 2 gases needed by the leaf. One is carbon dioxide, one is oxygen. All right, so how I can do this, because you can have 2 answers here, or one of 2 answers. So let's say we're gonna put, let me put this in 2. So I think I could do that. All right, so I'm gonna do this, and this will be an R, right? So I just want to show you how you could do this. So it's an R. So the first one I'm gonna put is carbon dioxide, which is the most common one that most of you will remember, that plants need carbon dioxide. All right, so plant need carbon dioxide. And the other option you can have is oxygen, right? So plants also need oxygen. All right, and I guess you should know this by now. I'm gonna tell you what carbon dioxide is used for. Carbon dioxide is used for photosynthesis. So this is used for photosynthesis. All right, so I'm gonna write for photosynthesis. And photosynthesis is the food making. All right, so to make food. I hope this could hold at the bottom here. To make food. Excellent, it's holding. Yep. All right, so to make food. Now, oxygen is needed for respiration. So this is one is for respiration. All right, because plants respire as well, right? And respiration means to make energy. All right, yep, to make energy. All right, so like all living things, plant will respire to make energy as well. So yes, so you can have carbon dioxide or you could have oxygen. All right. All right, so part B, it said the mesophyll of the leaf contains 2 layers with a different type of cell in each layer. It's a place on X on the diagram in the layer of the mesophyll. So we're going to part, now matter of fact, I'm going to highlight this because I said within the mesophyll. So you're going to place the X within the mesophyll, right, where gaseous exchange occurs in a leaf. All right, and so let's do that. Where in the mesophyll that gas exchange takes place, and label it X. All right, it's a rainy day today. I hope the rain is not affecting the background noise too much. All right, but these cells are the mesophyll spongy cells that I'm pointing to right now, and anywhere around these mesophyll cells or spongy mesophyll cells, you will actually have gaseous exchange takes place. because the gas will come in here, which call it the inter-here space or the interspace of the leaf or the air space of the leaf. And in those spaces, you will have gaseous exchange take place because these cells will take in the carbon dioxide and release the oxygen while they are photosynthesizing. Also, here as well, a matter of fact, you could even label here because at this point as well, in the palisade cells, you will also have gaseous exchange takes place. So anywhere around any of these cells, a matter of fact, your answer will be correct because all those cells will take in carbon dioxide to photosynthesize and release oxygen. So gas exchange takes place within the mesophyll around those cells. And notice the key part is within the mesophyll. And the reason I'm pointing out this because generally when you talk about gaseous exchange, you talk about the stomata. But this question is specific. This question is very specific because it said in the mesophyll layer. All right? So I just want to point it out. All right, now for part C, it says state the function of the structure labeled P and Q. State the function of the structure labeled P and Q, and let's go back with P. P is the waxy cuticle, Q is the palisade mesophyll cell. And so Q, again, with the waxy cuticle, it reduces water loss. So reduces water loss, all right, by reflecting light, okay, by reflecting light. All right, today is really a rainy day and a very nice day, motherfucker. Very beautiful day. So, very beautiful day for you to study as well. Hopefully, when you're studying, this is raining, cool and relaxing. All right, so Q now is to carry out photosynthesis, right? So, to carry out photosynthesis. All right. So, this is the main reason for these cells to carry out photosynthesis. And again, they are packed with chloroplasts, which means they are filled with chlorophyll as well. I have a part D of this question. Say diagrams show transverse section through 4 different types of leaves, and look at leaf A, B, C, and D. All right, and notice that they are different in their structures because of different layers. But let's read the question first to say exactly what is asked of us. It's the leaf A is from a plant that receives normal sunlight and normal amount of water. So leaf A will be your standard leaf. So this will be a standard, so everything will be judged based upon this. So this is a standard leaf right here. And you can know the different parts within this leaf. All right, so that's our standard, what we call our control. So if this was the experiment, this would be our standard leaf or our control leaf. All right, so for part 1 of this section, it says suggest which leaf is able to produce the greatest amount of starch if all 4 leaves were exposed to the same amount of sunlight. And so to produce the greatest amount of starch, it means that you must produce the greatest amount of sugar as well, which means that you must photosynthesize the most. So looking for which of these plants will photosynthesize the most, I'm going to point out something. And leaf B will be your answer because leaf B, if you notice it, it contains a lot of palisade mesophyll cells, and these cells are the ones that carry the most photosynthesis. So more palisade cells, it means that you have more photosynthesis taking place. That means more light will be absorbed and all of that. So leaf B will be our answer. All right, and it said explain the reason. So part 2 said explain the reason for your choice. And the reason for this choice is because it contains the most chloroplast. As simple as it. This leaf contains the most chloroplast. So this leaf contains the most chloroplast. All right, chloroplast. All right. Matter of fact, before I say chloroplast, let me say the most palisade cells first. Contain the most palisade. Contain the most palisade mesophyll cells. Contain the most palisade mesophyll cells. All right. Or you can say the thickest palisade mesophyll layer. You can say that as well. All right. So contain the most palisade mesophyll cells at 1. And also want to make a note right here, and then it's going to say which contains, all right, which contain the most chloroplast, all right? All right, so we're going to say that, and then we say hence, the most photosynthesis will occur. In this leaf, producing the most food. Producing the most food or starch, okay? Because once you have more food, it means that the sugar will convert to starch eventually, right? So yes, so leaf B is your answer because of a thicker waxy polysaccharide mesophyll cell. Thicker polysaccharide mesophyll cell, which means you have more layer, I should say. So thicker polysaccharide mesophyll layer, which contain more polysaccharide mesophyll cells, which contain the most chloroplast, and hence you have the most food being produced. It's a suggest which leaf comes from a plant that is adapted to grow in very dry or desert-like conditions. So let's go back to the leaf and see which of them you think will be adapted for dry areas or desert-like situations. And so what this leaf should represent is a leaf that will actually prevent water loss or to reduce the most water loss. That means water will be conserved within the leaf the most. And so the leaf that looks like here, let's point this out again. This layer right here is very thick in this leaf, which is called the upper epidermis. And the upper epidermis will protect the leaf from extreme evaporation or sunlight. And so if you notice, this one is thicker than all the others. So leaf D is the one that definitely will be adapted for desert or dry conditions. So leaf D is the answer. All right, and because of that thick upper epidermis, so this is leaf D. It's explain the reason for your choice, and the reason for your choice, it has the thickest upper epidermis. So this leaf has the thickest upper epidermis. Okay, upper epidermis. All right, so that has a thicker epidermis, and the epidermis will, as I said, will protect the leaf from excess water loss or evaporation. All right, so epidermis, which protects the leaf from excess water loss. All right. In other words, water will be conserved in the leaf itself. All right. So this is the end of another question. All right. So next question here is question number 3. So the mass and weight of an object is relative and of an object are related by the equation. So here now it said that weight is equal to mass times gravity, and we know that. All right. So and Dustin point out that weight is a form of a force. And so once I multiply the mass times gravity, get a force, which is the weight. All right. So that's something that you need to remember. And I know most of you remember that from previous workings. All right. Now we said the value of gravity on Earth is taken as 10 newtons per kilograms. And it said the value of G on the moon is 1.6 Newton per kilograms, which means the gravity is lower on the moon compared to that on the Earth. It said distinguish between the terms mass and weight. All right. And so mass, all right, and it said distinguish, which means you need to tell the difference between them. But what I'm going to do is to kind of give a definition first and I tell what is the difference, right? So mass is the amount of matter in an object, okay? In an object. And it does not change, okay? And it does not change regardless of position, or gravity. Let's put even gravity there, because no matter what gravity is acting on it, it will be the same. However, weight is different because this one now is how heavy the object is, how heavy the object is. All right, or heavy the object is. All right, and it depends on the position or gravity acting on it, right? So it changes based upon gravity. So when you have more gravity, it is heavier. Less gravity, it is lighter. So of course, the object will be lighter on the moon compared to that on the Earth, all right? And that's why objects will float around in space because they have little gravity. Now for part B1, it says state the name of the apparatus shown in the picture. And the name of this apparatus is called a triple beam balance. It's called a triple beam balance. All right, so the triple beam balance. And then here now it asks us now, state the value of the mass shown on the apparatus in B1. All right, so all right, well, in the diagram, it shows in the diagram, the apparatus. Okay, so the apparatus here, let's look at the mass here. So notice that there are 3 readings. So triple beam balance means 3. So there are 3 readings. I'm just going to highlight them. First, we start up with the biggest number, which is the hundreds, right? So we have hundreds, tens, and ones. So there are 3 levels on the triple beam balance. You have the hundreds, the tens, and the ones. And so on the hundreds, you notice this is pointed to 500. And the tens is going to the 40. And the ones is going to be right here. Let me just kind of highlight that where exactly it is. All right, and to figure out where this is, I just want to make a note that if you notice that between 0 and 1, there are 10 lines. That mean each of these lines are 0.1, right? So if this is 0.5, then it's going to be 0.4, right? So we're going to say this is, let me just write down the answer right here. So this is going to be 500. So the first reading, the biggest reading there is 500. So it's 500 plus 40. So it's 540. And then 2, so 42.4. Okay? So it's going to be 542.4 grams. All right, so that would be the mass on this triple beam balance. All right, let's go to the next question. So give the maximum mass this apparatus can measure. So what's the maximum mass this apparatus can measure? Let's just circle the maximum. So the maximum on the hundreds will be 500. And on the tens, it will go up to 100. And on the ones, it will go up to 10. So if you notice, this is going to be 610. Okay? So it'll be 610 grams. So this is maximum that this can actually measure, 610 grams. All right, so that's that for that part of this question. Let's jump in the next part of the question now. All right, I think I'm jumping too far. Okay, yeah, I should be right here. All right, this is a shopping bag has a mass of 0.2 kg. It contains one gram. It contains 1 kg bag of sugar, 0.6 kg grams tin of beans, and a 0.8 kg of chicken. It's a find the total mass of a shopping bag and its contents show all working. All right, so this is an easy mathematics for you, easy giveaway marks. I say you can earn this mark quite easily. Nothing too hard, because all it asks us to do is to find a total mass here, and the total mass we're gonna add all of these masses together. So we're gonna add the 0.2. So we're gonna say 0.2, which is that of a shopping bag itself, plus the contents, and the contents here we have a 1 kg bag of sugar, so going to be plus 1 kg there. All right, so plus 1 kg. Plus we have 0.6 kg of tin of beans, so 0.6 kg there. Plus we have 0.8 kg of chicken. And so once I plug this in the calculator, add up all of those, what you should get there is 2.6. We're going to get 2.6 kg of content, the bag plus its content. All right. All right. Next question here now. It said that find the weight of the shopping bag and its content on the earth show all working. So remember the formula for weight. Weight is equal to mass times gravity, right? I'm going to say weight is equal to mg, which is mass times gravity. All right. And so weight is also a force, just to point it out or to remind you that weight is a force. All right. And so our weight here is going to equal to our mass. And our mass, let's go back to our mass right here, which is 2.6. Yep, so mass up here, that's the same mass we're going to use right here is 2.6 kg. And remember, on the first part of the question, they give us that gravity is taken to be 10. So we're going to say that is equal to 2.6 times 10. All right, and that's the value of gravity. And so this will give us 26. And the value, and the unit, I should say, for weight is newtons. So that is 26 newtons. All right, next question, our next part of question here. Okay, this is the last part. Is to find the mass of a shopping bag and its content on the moon. All right, so ask to find the mass, and that's a matter of fact, I like this, the boldest. What is the mass of the shopping bag and its content on the moon? All right, so remember we talk about the mass of something does not change regardless of gravity. It remains the same. So the mass here is the exact same thing, 2.6. So no matter where you take it, it's going to be the same mass. So do not calculate anything. The mass is the same. So you're going to say 2.6 kg. And then remember, you can make a statement as well that the mass remains the same. Okay. So I'm going to put make a note here. Mass remains the same. Mass doesn't change at all. Weight do change. So if we wanted to find the weight on the moon, what it could do is to multiply the mass, which is 2.6 times 1.6, because the gravity on the moon in the question was 1.6, right? So if you want to find the weight on the moon, you could do that. Multiply the mass by the gravity on the moon. And so just in case you see that in the upcoming exam, you know exactly what to do. All right, so let's look at this question now. Question number 4, halfway in now. It's a diagram below show 2 sets of teeth in humans. All right, and so we notice that figure 1 and figure 2, they're a little bit different because the total number are shown in the middle right here. So the first one we have 20, and the next one we have 32. All right, so that's the difference in terms of number. All right, we also different type of teeth being shown here, A, B, C, and D. So there are 3 different types of teeth shown. All right, so notice in figure 1, there's no D there. All right, so I just want to mention that there's no D there at all. All right, so let's go down into talking about these answers now. All right, so for part A, identify which set of teeth belong to the permanent set and which one belong to the milk set. The milk set is also called the temporary teeth, and those are for babies or young children. All right, so the permanent set will be for figure 2. So let's put figure 2 right there. So those from figure 2, all right, and figure 2 they have more. I remember adult will be more teeth compared to infant, and so figure 1 will be the milk set. All right. Is to give a reason for your choice other than the total number of teeth. All right, so there are 2 reasons here. There are 2 options you can actually look up with right here. If you notice here in figure 1 on the milk set, D is absent. Notice that D is absent. They do not have the D set in it at all. Right, so D is absent. That's one answer. And also look at the teeth in figure 2. They're relatively bigger. All right, so notice even one at the front, these are a little bit bigger compared to these. All right, so these are generally larger than figure 1. So there are 2 answers there. All right, 2 possible answers. So let's give an answer right here. Is that the permanent ones, the permanent set are generally bigger. I'm gonna say generally, well, let's say bigger because the diagram showing that they're bigger, right? They're bigger. All right, so they're bigger, just to mention that. And also what is important again, or you can put there in the milk set or in the milk set or in the milk set type D, they say type D, which is a D set, type D is missing. All right, so type D are missing. So those set of teeth, they are actually missing, all right? All right, so there are 2 possible answers there, all right? So one or the other. Now for part B, it says select the tooth by using letter A, B, C, or D, which bites and cuts food material, so which is a cutting teeth. And cutting teeth, those are called the incisor, right? And so incisors, they are the chisel-shaped teeth that use to cut, and those are A. So that's A right there. So the cutting teeth, they are incisors, all right? And so those are A. And the one that know to chew and grind food, those are the bigger teeth. Those are the molar and also the premolar. So actually C and D, those are the same type of tooth. They use to crush and grind. So I'm put both answers there, C and D. All right, so they're similar in functions. So C and D, they do the same thing. They actually for grinding and crushing food. Okay, C and D. All right, and to tear food now, those are the canines. The canines now will tear food, is particularly meat. And so canines will be B. Okay, canines will be the B. Those are pointed teeth, very pointed teeth. So those are the B right there. All right. Now it's a give the name of the substance in most toothpaste which helps to prevent tooth decay, and that is the fluoride or fluorine. So this is the fluoride. The fluoride is the name of that substance within toothpaste that will help to prevent tooth decay. And here is explain how this substance does this. And what it does is to strengthen or harden the enamel. All right, so it strengthens. All right, so it strengthens. I think I make a mistake right here. Yeah. So it strengthens. All right. Come on. Yeah. Or hardens. So strengthen or hardens the enamel. All right. So that's what's happening there. All right. So strengthens or harden the enamel. So make the enamel get harder, which is the outermost part of the teeth, right? That's the white part. Make that part really hard and strong. All right. Yeah. So it's very hard for bacteria to decay through it or to decay it. All right. So part D now is to describe the role of the teeth in the digestive process. So what's the function of the teeth in the digestive system? And when you say the teeth, it means generally the teeth, right? Not just a specific teeth. All right. So overall, what teeth does. Now, so the function of teeth is really, let me say, teeth mechanically, or physically, same thing, all right? Mechanically or physically. And the reason I'm using the word mechanical or physically because the digestive process, right? So you can say mechanical digestion or physical digestion. So the teeth mechanically or physically break down food into smaller or simpler, into smaller pieces, right? Let's say smaller pieces. All right, smaller pieces so that enzymes, because enzymes now can work better, so that enzymes can work more effectively. All right, can work effectively in breaking down the food chemically, or the chemically, or effectively in chemically breaking. Let me say chemically breaking down the food, right? Or work effectively in chemically, because now the enzymes are chemical digestion, right? The chemically breaking down the food. All right, so yeah. So the teeth is have to break down the food physically first, to make it smaller pieces, so when enzyme penetrate it easier, and so you have a faster and a more effective reaction by the enzymes. All right, so that will be the end of that question. For question number 5 now, it said the Earth crust, right, contains metals and metal compounds. It's in order to be useful, metals have to be extracted from the substances that they are mixed with. It's a table now shows the three metals, X, Y, and Z, and the method used to extract them. So X is extracted by using carbon, reduction using carbon, and Y is found uncombined in the Earth crust, and Z now is electrolysis. So electrolysis Z, and when you hear electrolysis, you should know which metal comes to your mind right there, because it's a famous question in the chemistry exam and also in the combined science exam. All right. So a matter of fact, in most even science classes as well, you talk about extraction of a particular metal, they use it electrolysis. So for part 1 now, it says state why metal Z is extracted by electrolysis, but metal X by reduction using with carbon. And I just want to make a little notation right here that when you're talking about extraction of metals, you're thinking about the reaction of metals. So metals are reactive. So you have what they call electrolysis series of metals. And so if you think about it, let me see if I could do this. All right, there is a carbon compound. So I'm going to let's put aluminum first, right? So the important metals that you should know is actually aluminum. That's what we normally extract. We extract also, let me put carbon right here. And so carbon will be there. I'm going to put in all the metals. I just put in the common ones in the series. And then you will have zinc, so you have Zn, you have zinc, you'd have iron, which is Fe, and you have tin, which is Sn. All right. So what I want to point out is that these three, all right, are not necessarily in perfect order, but these three fall below carbon, right? And so the arrow in terms of the series go like this. So generally, the metals that are above carbon will need electrolysis to extract. The one below carbon, they can extract easily by reduction with carbon. All right, all right, and so not only that, the one at the bottom also they are below carbon. They are less reactive than carbon as well. All right, so carbon can use to extract them. All right, and the one above carbon, they are generally more reactive than carbon. All right, and so also they're more difficult to be extract from the ore, and so it requires a lot of energy and all of that type of a lot of energy is required, a lot of long processes, and so you have to take care in removing them. And so electrolysis is normally used, even though it's a very expensive process. All right, the others are easier to be extracted. And a matter of fact, if you go even lower than this, you get like gold and so on. I could put even gold here. Yeah, I could put gold here, right, which is AU. All right, and silver as well will be there as well. A silver, gold, copper, those will be at the bottom right there, right? Those are pretty much easy as well to be extracted. All right, so let's answer the question. It's a state why. Okay, let's answer this one. Yes, state why metal Z is extracted by electrolysis, but metal X is by reduction with carbon. And what I was explaining is pretty much what I'm gonna put right here. And so for 2 marks, there are a number of things I could talk about. One is that Z is more reactive, okay, which is in this case could be aluminum, right? So Z, metal Z, let's start with metal Z. Metal Z is more reactive, all right, is more reactive than carbon, all right? So just to make a note of that. Unless I'm gonna put them across that. So I'm gonna give in pointers, all right? So while while X is less reactive, okay, than carbon. And when I say less reactive, I mean a reacting with carbon I'm talking about, right? So less reactive. All right, so that's 1 point right there. I'm gonna give another point. I'm just put these in pointers, so at least we know. So let's give another point right here that they can actually have. Metal Z is harder to be extracted, right? So it's harder to extract. So it's harder to extract. All right. So you need a high energy process or a process that will actually separate the molecules from the ore. So electrolysis is a good way to do that. All right. So metal Z is harder to extract, and of course X will be easier. All right. So while X is easier, all right, so that's another point right there. Let me give another point as well. So there are a number of points you can actually have here. Let me say what I could say here now. Yeah, metal Z. There's another point I'm thinking about here. Metal Z loses electron easier, because once you lose electron easier compared to the rest, it therefore means that in electrolysis, electrons must be easily given away or added. So in other words, yeah, oxidation reduction can take place easily. Without oxidation reduction taking place in electrolysis, then the process will not take place. So yeah, so metal Z loses electrons, all right, easier than metal X. All right, so those are some points that we can have right there. All right, so those are general points, a matter of fact. And so when I say loses electrons, though, which means it's easier to oxidize. All right, so loss of electrons is actually is oxidation, so it's easier to oxidize compared to metal X. All right, and remember that there are 2 types of oxidation. Oxidation can be defined as gain of oxygen or the loss of electrons. But and reduction now is defined as either you lose oxygen or gain of electrons, and that's why X can easily be reduced using carbon. All right, so yeah, those are 3 possible answers you could have there. For part 2, is to suggest the names of metal X, Z, but metal X by reduction with carbon. All right, so suggest the names of metal X and Z, why I don't understand the statement, but let's just, it says suggest the names of metal X and Z, but metal X. Okay. I see. They're just giving the information based on the chart, what they give out the process. All right, so let's just name them quickly. So X could be X reduction by carbon, that is normally iron. So let's put iron there. That will be iron, and the symbol for iron is Fe. So I must put iron, which is iron, and the symbol for iron is actually Fe. So you need to know the extraction of metals, the process of extracting metals. You really need to go through those. And Z now, of course, it will be aluminum. All right. And it's a suggest which of these metals X, Y, or Z was first obtained for the use by man. And I want to point out something here because this is going to be very important. Let me just go back to the chart. For metal X, there could be more than one answers because truthfully you have iron, that is Fe. You also have zinc that could also be extracted in this way, and also tin. So any of these three that I put on the side there, they can actually be extracted using reduction by carbon. That's why they are below carbon, as a matter of fact, right? And found uncombined in the earth, you have a number of metals as well. So I'm gonna give you the possible options you could put here. So gold, which is Au, copper, which is Cu, all right, and also silver, which is Ag, all right. So any of those can be separated from the earth because they're uncombined, which means they're in a ore, for example, they're just in a natural form. All right, and electrolysis is generally aluminum, right? So again, let's fill in here. Again, what you can put, which is the first metal to be used or obtained by man, is actually the element here is actually copper. All right, copper is the very first metal used by man. All right, so copper could be your answer right here, and so copper will fall in the category of Y. So that means Y is our answer. So you're gonna put Y there, okay? And again, because it contains copper, gold, or silver. Gold is not the first metal used by man. Gold is the most expensive metal used by man because gold, based on its perceived value, and it becomes very expensive and most sought after metal. But copper is the very first metal that was used by man. Just a bit of information there. Now, next part of the question is aluminum is the most abundant metallic element in the earth crust. Name the ore from which aluminum is obtained, and aluminum is obtained from what they call bauxite. All right, the ore for aluminum is bauxite, and I know most of you remember that as well. For part two, it said name the other raw material used in the extraction of aluminum and explain why it is used. And the name of this is actually creolite. Most of you just say creolite. Creolite is accepted, or you can just say molten creolite. All right, so let's put the correct version is molten creolite. All right. Again, most of you just say creolite, but it's actually molten form. It has to be a molten form. All right, and how it is used or why it is used is simple. It is used to, and put it right here. It is used to lower the melting point, of aluminum. I said lower the melting point of aluminum. All right, aluminum oxide, a matter of fact. All right, because the thing is, to extract aluminum, it really requires a lot of energy, and so you have to lower the melting point to be easier and cheaper method. So it actually reduce the cost or the amount of energy required to extract aluminum. That's the purpose of creolite. All right, because a very hard metal to be molten. All right, from its ore. Matter of fact, bauxite is a lot of process, a lot of energy requires to actually do that. All right, so again, the purpose of the creolite, it is also it also cause, let me put that part, is also cause the ions to move freely. Ions to move freely. And aluminum oxide. All right, so yeah. So just to make a note that it causes ions to move freely in aluminum oxide. And remember that electrolysis uses the movement of ions or electrons. And so when the ions are able to move to different electrodes easier, then the process will be much faster, right? If the ions are not free, right, or the free radicals are not free, then the electrolysis process will take a longer time or not occur at all. So it's very important for that process. All right. The next part here is to give one use of aluminum and the physical properties responsible for it to have this use. And so there are many different use of aluminum. Many. I think it's used so many different things. It's unbelievable. But all of us use foils, so it's used in foils. It also can be found in making windows in your homes, windows and doors. So let's say windows and doors. All right, so using windows and doors. Is used in aircraft as well. Used in aircraft to make parts in different parts of aircraft. It's used in different parts of a building, in a kitchen, used to make materials in the kitchens and so on. And the reason for that is really for the many uses. I'm saying there are tons of use for aluminum. And so the reason for all of them is really because it's actually lightweight. So aluminum is really lightweight. And not only lightweight, is also flexible. Let me put lightweight and flexible. So you can bend it easily, can make different shapes out of it. Very easy to use. The only difference now is the welding process. The weld aluminum is a little bit more difficult than welding other metals. But generally, because it's lightweight and it's flexible, yeah, it's definitely better to use and easier to use. Number 6. And we're trickling down to the end. So he said this graph now shows the speed of a motorcyclist changes on a short journey. So these are some changes right here. And they said, so we have speed on the y-axis, time on the x-axis. So it's the velocity time graph. And now we said describe the motion of the motorcyclist during each stage of the journey, A to B to C, C to D. And unfortunately, no, we do not have, okay, and D to E as well. We do not have these on a graph. But by means of logics, though, we know that A must be here, right? Let's call that A. So that must be a typo. This is B. We're going to put in our own. But I'm sure that's what they actually meant, right? It's just a typo. C, here will be D, all right, and then here will be E, okay? So that will be the motions we're going to describe right there. So let's describe those. Between A and B, there's an increase in speed, so that is acceleration. So we're going to say acceleration, all right, acceleration. And for acceleration here, just to make a note, right? All right, for acceleration, just to make a quick notation right here, you can actually describe it a little bit better by stating that there's an increase in speed, right? So the speed increase to 10 meters per second in 20 seconds. So you can say it starts from rest. So let's say start from rest, and increase in speed to 10 meters per second, right? I'm just gonna quickly say, hopefully it's all is good hold here. 10 meters per second in 20 seconds. All right, in 20 seconds. All right, so, all right, in 20 seconds. All right, what I'm gonna do, I'm reduce the font size here so it could hold on that line. Let's put it to that. Yeah. So acceleration, it starts from rest and increase in speed in 10 meters per second to 10 meters per second in 20 seconds. So the exact what is happening here. It starts from rest 0, increase to 10 meters per second in 20 seconds, right? And actually, this is an acceleration right here. So it's accelerating. Let me just change the word acceleration to accelerating. All right, let's go to part B now to C now. In part B and C, what is taking place here? What you notice here that the speed is not changing. So what we're going to say here is moving with steady speed, all right, or constant speed. So moving constantly or with constant speed, constant or steady speed doesn't really matter. So moving with constant speed or steady speed. All right, and so you can also explain this that it moves at constant speed, let's say of 10 meters per second, right? Of 10 meters per second for, and this from 20 to 40 is 20 seconds, right? for 20 seconds. All right, so that's what is happening at part B to C. Part C to D now. C to D is another increase in speed again, so that's another acceleration. So again, it is also accelerating here. So it's accelerating here. All right, so it's accelerating here as well. And it accelerates from, so we're going to say accelerate from, let's say from, that's what, 10 meters per second. All right, so accelerate from 10 meters per second to 40 meters per second. 40 meters per second within, and the time it takes from here to here is just 20 seconds, right? For 20 seconds. All right. So that's another point right there again. All right, so the last part now, which is D to E, I notice there's a decrease in speed here, so there's a deceleration, so decelerating. So here it's going to decelerate, so it's decelerating, and it's decelerating again, and it starts, let me go back up, so it's the maximum speed. The matter of fact, it comes from 40 because we can use actually that to help us go up to 40. Yes, so it's 40 if you look at the graph, and it comes down to 0. So it's accelerating, and it starts from, so let's say from 40 meters per second to rest or to a stop, to a stop. For 0 or to rest, stop or rest. Let me put rest, which means stop. All right, so it's decelerating from 40 meters per second to a stop. And it does this in, if we go back to the graph, in, let's see what the time it takes to do this. From a 40 to this is going to 60 to 100, that's actually 40 seconds, right? Yeah, so in 40 seconds. In 40 seconds. All right, and those will be our answers there. All right, so for part 2 now, is to calculate the acceleration of the motorcyclist during the first 20 seconds. So I want to find the acceleration here. And notice here, acceleration, let's give you a quick rundown what acceleration is. So acceleration is a change of speed over time, right? Or velocity over time. The change of speed or change of velocity over time. And so the velocity here, the change of velocity is going to be, let's go back and show you in the graph. Here, the velocity, the maximum is 10, so you move from 0 to 10. So the change is from 10 to 0 to 10. The time is 20 seconds. And so what you can have here, let me just quickly show you, could work this out. It'll be 10 minus 0, all right? 10 minus 0 divided by, the time was 20 minus 0. So a change of time over a change of speed. And so technically is 10 over 0. So you can just say 10 over 0, 10 over 20, I should say, sorry, 10 over 20. And 10 divided by 20, what you get there is 0.5. So that's going to be 0.5 meters per second squared. So that will be acceleration there, right? It's velocity over time. All right, so for part 3 now, so the total mass of the motorcycle and the motorcyclist is 220 kilograms. All right, so this is not a question. This is not a question at all. So let's try this out. This was a statement. This must be a typo. They actually want to do something from this. So this is a typo here. So you gain these 2 marks in the examination because this is not a question. All right, it's not a question at all. It's a statement that the motorcycle and the thing is 280 kilograms. All right, so let's go to the next question though to see exactly what is being asked there. So that's a typo there for the examination. In this case, you get the marks for that part, all right? Now, let's calculate the force needed to cause the acceleration in the first 20 seconds shown in the graph. And so just to make a note right here that to find force, force is equal to mass times acceleration, right? So mass times acceleration is force. Let me just increase this back to a bigger thing. All right. So force is equal to mass times acceleration. And so we have the mass because they gave us the mass right here. I think that's why they actually gave us the mass right here. So this is 220 kg. And our acceleration was, let me go back to the acceleration in that part, is 0.5. So 0.5 is the acceleration. All right, so 0.5 is the acceleration. All right, so let's quickly do that now. So the mass here, go to find the force. So force is equal to mass, which is 220 kilograms, multiplied by the acceleration, which is 0.5. All right, and so that will equal to 1110 newtons. The value, the unit for force is the newtons. All right, so that will be your answer for that question, or part of that question. All right, so again, you the person who have done this exam would have gotten that 2 marks free. They are so lucky. All right, so question number 7, and we really get into the end now. It's a diagram shows the diagrams The diagram shows the steps in an investigation to test for proteins, right? So you're going to test for proteins, and you know that we use the burette solution. It's a few drops of reagent, and the reagents we're going to use for testing burette is burette to test for protein is actually the burette solution. All right, just to make a note right there. All right, and the color change here that you should see if your protein is purple. You remember that from our experiment. All right, so we get purple for protein. All right, and so let's answer the question. So name the reagent used right here, and again, burette. All right, so there's no even need to discuss that. All right, and then ask here now, state the final color change, the color in this test tube, which shows a positive test, and this is purple or violet. You can also put violet as well. That is also given as an answer. All right, so violet or purple. So let's put purple here. All right. All right, so that's the answer there. It said what mechanical action must be taken to activate the color change in the test tube? And it's a mechanical, which is a physical thing. So all you need to do is to actually mix or shake the test tube, right? So you're going to mix the content, or what you can do, or you can shake the test tube, okay? So you're going to shake the test tube. You can put a little steering rod inside of it and mix, or you can just shake the test tube. All right, shake the test tube. All right, so give a nice little shake so the substances could mix together and cause a reaction. All right, so let's go into the next part of the question now. It's a name two elements which are components of a protein molecule, and protein actually contain a number of different elements, and it's a name two. So I'm going to give you more than two. So you can, what is very important, I'm going to have carbon. Carbon is in the macromolecules that you should know. Hydrogen is also there. Hydrogen is also there. What is also there is oxygen. All right. And what makes protein different from the other, the others I'm talking about is carbohydrates and fat, is that it contains nitrogen. All right. So it contains nitrogen and sometimes sulfur. But the main one that you must put in, all proteins must contain CHO and N, all of them. Only some contain sulfur or phosphorus, right? Carbohydrate is a CHO, carbon, hydrogen, oxygen. Fat, same thing, CHO, carbon, hydrogen, oxygen, right? So what separates proteins from the rest is actually nitrogen. Next part of a question. So kwashiorkor is a deficiency disease resulting from a lack of protein in the diet. It affects infants once they have been weaned from breast milk. And wean means stop giving them the breast milk, right? Explain the reason for this. So the reason for this is simple because breast milk, let's say breast milk provides sufficient protein for a baby. Okay, so provide sufficient protein for a baby. That's very important. And so now the diet. So let me say if the diet after breastfeeding, is not substituted with adequate, let's say adequate amount of proteins, then the child will lack protein or have a deficiency in protein, right? So the child will lack or have a deficiency in protein, all right? And hence you will see the symptoms of kwashiorkor. And kwashiorkor, if you lack protein, what's going to happen is that you have a pot belly and a wasted muscle, so you actually could see the bones of a person's through, all right? All right, so definitely lack of protein will be caused if the diet after is not supplied with the correct amount of proteins. In other words, the child will have an unbalanced diet. All right, for part D, it said name the waste product formed when amino acids are metabolized. So when amino acids are metabolized, so if you have excess amino acid, what you're going to get here is urea. Urea will eventually form. All right? All right. And the process that does this is what they call deamination. So urea is formed from deamination whenever you have excess amino acids, right? It's a name the organ where amino acids are metabolized, and this is taking place in the liver. All right, deamination takes place in the liver. It's a name one substance in our bodies that are made from proteins, and there are many things that are made from proteins. We have our muscles are made from proteins. Hormones are also made from proteins. And the one that you should always know is that enzymes, they're always proteins. So enzymes, of course, are proteins. Also, antibodies are also made of proteins as well. So there are many different substances we can list that are made from proteins. So these are just the common ones that you should remember, at least remember, that are made from protein. All right, and so we're going to a final question now. And it said, energy cannot be created or destroyed, but is transformed from one form to another. And here we have a energy input and energy output in a car engine. So this is a car engine question here, or based upon energy. It said energy transformation can take place in a car engine. Is a fill in the blank spaces to complete the sentence. And so in a car engine, energy in the fuel is transformed to. So what type of energy in the fuel? And that's chemical energy. Fuel is going to be chemical energy, so there's going to be chemical energy. Is transformed to energy in the engines and the wheels of the car. So the wheels are moving, so there's going to be kinetic energy or mechanical energy, right? Kinetic energy or mechanical energy, whichever one you want to put, that's fine. But kinetic energy, I prefer that because it deals energy with movements. Also, mechanical energy, same thing as kinetic energy as well, right? All right. For part B, it's only 20%. It's only 20% of energy from fuel put into a car is actually used by the car to move it down a road. It's a car is supplied with 2,400 joules of energy. All right, 2,400 joules of energy. How much of this energy in joules is wasted? And so we're going to say if 20% is used, right, then 80% is lost or been wasted. So we're going to find 80% of 2,400. So 80% going to say, okay, 80 divided by 100, and then all of that now going to multiply by 2,400, and that will equal to 1,920 joules. So 1,920 joules of energy will be wasted. All right, it will be gone. It's a name two forms. Name two forms that is that this wasted energy is most likely to take. So what are the form of energy that the wasted energy will be in? And so generally, if you think about a car engine, you get heat from that, right? Or what they call thermal energy. So heat or thermal energy. Okay, that's the type of energy that will be wasted because the engine will get hot. That's why you have fans in the engine, right? Also, you get sound because once it is moving, you get sound as well. All right, and so the fan is moving, which is using energy as well. If you turn on the radio, you also use energy as well. So pretty much everything you do in it, you actually waste energy for all of that. So sound, heat, those are the general ones that is energy is wasted in. All right. All right. So yes. All right. So let's go to the next part of this question now, and we're almost there. We're getting right there. It said the combustion of fuel releases energy. Name the gas required for the combustion of fuel. And for any combustion, a matter of fact, once you're going to combust anything, it must have oxygen. If without oxygen, you cannot have combustion, right? So oxygen is very important for all combustion. And to give the name of reactions which produce energy. So the name of reaction that produce energy is actually called exothermic reaction. Exothermic reaction will give off heat energy to its surrounding. So once it's producing heat energy, it is actually called exothermic. Endothermic reactions, they are the one that actually absorb energy, that they need energy for them to take place. So again, it's a reactions. I just want to make sure you understand that the chemical process is exothermic. All right, next part of the question here is that hydrogen can be used as a fuel. The combustion of hydrogen produces a non-polluting product. So combust hydrogen, it produces a non-polluting product. Is a given name of the non-polluting product produced from the combustion of hydrogen. So I wanted us to know this is a chemical reaction, is that for hydrogen to combust is actually hydrogen plus oxygen. So think about hydrogen, which is actually hydrogen gas. Let's put H2. All right, you know what? Let me write it in. It's better to do that. So what you're going to have is actually H2, which is hydrogen gas, reacting with oxygen. So a matter of fact, once I do this, you're going to see exactly the product that will form. reacting with oxygen. It's not as simple as drawing it though, because there are other things that take place or stages of reaction taking place there. So if you react these two, what you're gonna get is H2 at the end plus some energy, right? So you're gonna H2O plus energy. All right, so you're gonna get energy as well. Let's just put E for energy, all right? To get some energy as well. All right. And it's going to be heat energy, so I could just put change of H with change of energy. All right, that's fine. Just remember that E in this case is energy. All right, so give the name of a non-polluting product, and that is water, with this H2O. So this is water, H2O. And for part 2 now, it's a describe the test that could be used to identify the non-polluting product identified. And so there are a number of different tests you can use to test for water, and this is the end of it. All right, so the number of tests, the tests that we can use here is a temperature test. So one is a temperature test, and the temperature test. And since water is going to be in a vapor, you're going to know that it's going to boil at or evaporate at 100 degrees Celsius, right? So you can actually test the boiling point or the temperature or the temperature of the gas. So the boiling point here is 100 degrees Celsius. So 100 degrees Celsius. All right, just know that is 100 degrees Celsius. All right, and of course you can freeze it as well. And if it's pure water, then you're going to freeze at 0 degrees Celsius. Another test you can use here is the use of copper sulfate. So you're going to use let's say use pure, because this must be pure. Use pure copper 2 sulfate, all right? Use pure copper 2 sulfate. And the reason why I'm saying use pure copper sulfate is simple because copper sulfate is white. They must put white in bracket because it's going to be a white substance. If it's pure, and they use pure copper sulfate and react with water and react with the substance of water and react with water. All right, let me take that off and react with water. All right, react it with the water or the substance that is named up there. And what is going to happen, it's going to turn into a blue substance. So what you're going to get here is going to form a blue substance, right? So it will form a blue substance. And the blue substance going to form here is going to be copper 2 sulfate, right? And that's going to be in some amount of water crystallization. They'll form a blue substance, which is still copper 2 sulfate, just to make a note of that. But the difference is because it contains water crystallization, then it's going to be blue. And another test you can use for water here as well is what they call the cobalt test. So you're going to use here in this case is a anhydrous. In this case is anhydrous copper cobalt. I'm saying cobalt 2 chloride. We call that the cobalt test, right? 2 chloride. All right. And what will happen here? It will turn from blue to, this is going to be blue, and so it will turn into purple. So using anhydrous it will turn cobalt chloride. It will turn into a pink. I said purple just now. It's pink actually. All right, turn into pink. All right, yeah. And so those are the 3 tests you can use to test for water. And this is the end of this review. Again, good luck on the examination. I'll talk to you soon.